Okay, so next is how many types of protocols are there. So two types, communication protocol, interface protocol, and this communication protocol, they are also known as serial protocol. Serial protocol means data is transferred serially, bit by bit. Here your speed will be less, and with that area is also less requirement. Okay, so in parallel protocol, here in serial protocol, your speed is less compared to interface protocol. Okay, but your area is more. Why area is more? Because you have to convert the parallel to serial, then you have to transfer the data, again you have to convert serial to parallel. And if I'm talking about area is less here, if I'm talking about parallel protocol, here speed is more, area is also more. Okay, let me give an example. What is this serial and parallel? Area in the sense I'm talking about bus requirement. Okay, so this is one protocol. So if I'm going to transfer data from here to here, I'll be needing only this one bus if it is a serial data transfer. But if it is a parallel data transfer, then I'll be needing more buses. Like I want to transfer 32 bits of data, then I have to add 32 buses here. Okay, so number of data size increases means your bus requirement will increase. But here, how many number of data or data bit, that does not matter. You just have one line to transfer the data. Okay. So understood about this, how many types of protocol? Hello.
Yes, ma'am.
Okay, so please go through these things. Okay, so now next thing is so many types of protocols are there. Which protocol you have to learn? Okay, so normally as a fresher, they expect you to learn the AMBA protocol. In the AMBA, APB, AHB, ASIC, and in the serial protocol you can go I2C. Then I2C is important, UART is optional. You can work on this, but I2C is important. Okay, so next thing is, okay, instead of like here I'll be explaining you these things in Verilog, system Verilog, UVM. In Verilog I'll be explaining its design. But if you are going like these protocols AHB, XI, don't go to design, because design it will take more time. So just take, so in AHB, XI there are so many features. Okay, I will give the next class, if possible I will give some brief explanation about AHB and XI, but they have so many features. You can just pick up 5 to 6 features and write some system Verilog code to verify them. Before that, you have to learn its all features. That is very important, because if you are going to interview and you are saying I have worked on these things, then first of all they will be asking its functionality. Let you have not done the code, you can simply say I have knowledge on HBXI. If given a chance, I can work on this. So first of all, they will be asking this functionality, APB, whether APB, HBXI, their functionality. So these things you have to be clear. So as a fresher, this AXI or HB, only one protocol you can learn, because these two things are very similar, and APB must. Okay, so these things you have to learn. So now going through this, what is this APB protocol? Okay, so now communication protocol and interface protocol, what is the difference between them? Okay, so communication protocol, communication protocols means it is also used to do the data transfer. Okay, there are one chip and another chip, you want to do data transfer from one chip to another chip. Okay, just this is one memory and this is another memory. Now you want to do data transfer from this memory to this memory. So you have to follow certain rule. Let you are saying that, okay, I am going to follow the rule of I2C. Then this will be known as I2C master and this will be known as I2C slave. Now, whatever rules defined in I2C, you have to follow them. to do the data transfer from here to here. What is master, what is slave, I will tell later. Okay, so now let this one is I2C. So I2C master, I2C slave. You are going to do the data transfer, not a problem. Okay, but let you are saying that okay, this master is I2C but slave is not I2C. I am going to follow that slave should be UART, or let's okay, slave is UART. So now UART it have 4 pins, I2C it have 2 pins. You cannot directly connect I2C to UART. If it is I2C master, I2C slave, it has 2 pin, you can directly connect them. But if it is I2C master and it is UART slave, then you cannot connect them directly. So for this, I need interface protocol. Interface protocol means this AMBA protocol. So now in AMBA, I have APB, HB, ASIC. So which one should I use here? So remember, whenever you are doing with low speed, go for APB. APB is used for low speed. So here there will be one APB bridge. Now you have to convert I2C pin to APB pin, then APB pin to UART pin. So it will be I2C to APB. These all things you have to do in coding only. And here APB to UART. So now data will be transformed from I2C to UART. So this is the work of APB, or you can say this AMBA protocol. Yes.
Ma'am, can't we do like that? We can directly transfer from I2C to UART. That why we are bridging this in like APB.
Okay, I2C it have actually 2 pins. Okay, UART it has 4 pins. So for which, how you are going to connect this 2 pin to 4 pin?
Okay, ma'am. And what about APB?
APB has like 10 number of pins, but its work is whatever the pins here, 2 pins, it will according to connect here. See, it has so many pins. Okay, so now in this 2 pin, I2C will be transferring the data and another will be clock. And in okay, I2C, okay, see in I2C, one so like wire is there to transfer the data from master to slave, slave to master within this one wire. But in UART, it has 2 wires. One is master to slave, another is slave to master. So you can say I need some controlling mechanism. I cannot directly connect them. I need some controlling mechanism who will control how the data will be transformed from here to here. That controlling mechanism, you can say it is APB. Understood? Okay. So now, so if let here instead of UART, I have some PCIe. PCIe means again it is a high speed. So high speed means I cannot use APB. APB I can use for I2C, but for PCIe I cannot use APB. So here I have to go for AHB or AXI. AHB or AXI. So here it will be I2C to APB. Here it will be AXI to UART, AXI to PCIe. Then here APB to AXI. So remember, whenever you are dealing with 2 different communication protocol, master is one type, slave is another type. So there you need interface protocol. Okay.
Okay, ma'am.
Okay, so now what is this master and what is this slave? Anyone can be master and slave. Okay, so master means the one who initiates the transfer.
And ma'am, communication protocol वहाँ चाहिएगा जहाँ पे बस 2 चिप का direct हम
communication protocol means you can say it is like a peripheral protocol or on-chip protocol. Means see in the here there will be it is like one type of memory only. Like if I'm talking about RAM is also one type of memory. If I'm taking 2 RAM, then I can do data transfer from here to here. But there is no certain rules defined. If there is no rule, then you have fabricated one RAM and another one is going to use that. You have to give them some instruction, right? Like you should be doing the data transfer like this, that. So RAM does not have something like that. But if I'm going to I2C, in I2C there will be one memory. Let you are talking about I2C master, there will be one memory. Okay, so from that memory, master will be writing the data to slave. But in I2C, they have certain rules, like there will be only one where in this one where first master will send data to slave. If slave is receiving the data, then slave will send one acknowledgement. Then again, master will send some data. If slave is not receiving the data, then slave will not send any acknowledgement. So master will understand that there is some error in data transfer. So master will drop that transaction. So this kind of rules are defined for I2C. But is there this kind of rules for RAM? No. If there is no rules, means you cannot say my data transfer happened properly or not, whether there is an error or not. Okay, so I2C means you can think like it is a memory only, like communication protocol, it is one kind of memory. Slave means master is writing the data into slave and master will be reading the data from the slave. So if there is no memory, then how you are going to write the data and read the data? Memory is there, memory plus certain predefined rules to do the data transfer properly. Understood?
And ma'am, interface protocol do not have any memory, right?
No, they don't have any memory. They just pass the data from here to here, like.
Okay.
Okay. So now if I, okay, so master means the one who initiates the transfer, slave means the one who responds the transfer. So there is nothing fixed like it will be I2C master and it will be I2C slave. Okay, there are two components. Now this component send the signal to start the transaction. So this component will be master, this will be slave. Now let this component both have memories, both can write the data into one another. Now let this one started send some instruction that I want to send the data transfer. So it will be master, next one it will be slave. So the one who initiates the transaction, that is master, and master will be sending all the signals. Slave just have to respond it. Okay. And if I'm talking about my main processor in my system, that will be always a master because it is the one who is controlling all the things. Expect that processor, if you are taking any other component, their component, they can act like a master or act like a slave. Okay. Understood master slave concept?
Yes, ma'am.
Yes.
Okay, so now I'm going about APB. So today I'm just talking about APB. In the next class, I'll be giving some, you just go through APB protocol today. Next week, I'll be giving some brief introduction about AHB and XI. Okay. So APB, it is advanced peripheral bus. Where it is used for low speed, low bandwidth components. Okay. So I just gave an example. If you have I2C, then go for APB protocol. If you have PCIe, then APB protocol won't work there. Okay. So now you can download this PDF, okay, directly AMBA APB protocol specification. From there, you can go through this protocol. Okay. So now, first of all, I have to explain there are so many pins are there. So what are those pins and what is the work of those pins? If it is disconnected, then please connect again. Okay. So these are the pins here. I'll be explaining one by one. Okay. Okay, so for two signals will be constants in all protocol. One is clock and another is reset n. Why this small n is used? So in whatever signals, if they are using the small n stands for negate. Means this reset will be working for negate. Okay, so now as it is a APB protocol, so I will be adding this PS. Okay, P means APB protocol. H means HB protocol. Okay. So P clock means this is the main clock. It will be generated by master. And P reset means negate reset signal. Now next is P select X. Okay, so now there are these two things they may ask you. What is this N stands for and what is this X stands for? N stands for negate, X stands for number of slaves. Let you want to use let 4 number of slaves. So this is our master. 1, 2, 3, 4. So here this master will have 4-bit select X signal. 4 select X signal will be there. 1, 2, 3, 4. And they will be connected. Here another slave, another slave, and another slave. Now let master want to do the data transfer with this slave. So master will make this signal as 1 and this is 0, 0, 0. Okay. So now one slave will get selected. Now let master want to select this slave. So master have to make this signal as 1 and this signal as 0. So can you tell me which kind of circuit I should use here? Okay. Which circuit?
Decoder.
Yes.
Decoder.
Decoder. Normally decoder is used to select a chip or select a slave. Okay. Here I can say decoder is used to select a chip or slave. Okay, so now this P select X means let here 7 means 7 number of slaves, 3 means 3 number of slaves. So now the question is how many number of slaves I can use. Normally this depends on the fan out of your master. Okay, how many slaves it can drive. Normally it is fixed like 16 slaves. Okay. Fan out, or you can say output capacitance of master. Okay, but if I'm going through practically how many, normally there you take 60 number of slaves. Okay, they have fixed it. Okay, you can take more if your master have more like these things, but normally they have taken like you should not take more than 16 slaves. Okay. So now this is to select a slave. Okay. Now the question is if I have multiple master. Now let here there is one master. Here there is another master. I have 3 masters. And here let I have 1 slave. Now master is the one who is going to do the transaction. In the previous case, master has the right to select the slave. Which slave it should select. Now slave does not have any right to select the master. So now in which way this master will get selected? That which master will be connecting to this slave. So this technique, it is known as arbitration. Arbitration means if multiple masters are there, then arbitration technique is used to select which master will communicate with slave. So many types of arbitration technique is there. Okay, commonly used is round robin. You can go through like FIFO also. Okay. This FIFO means which master will come first, that master will be given the access. Let this master come first. So first this master, then this master, then this master. Okay, round robin means, okay, first this one. Okay, let you started from here. You can start any master. See, FIFO means which master is first, that master will be given to access. Round robin means you can prioritize. Let you wanted to start from here. So first this master given, then this master, then this master. Okay, let you want to start with this master. You can start with this master. First, this master will communicate with this slave, then this master, then this master. Okay, so arbitration means you are selecting which master you are going to communicate with slave. Okay, and decoder circuit is used to select which slave master is going to communicate. For this arbitration technique, you can use, like if I'm going to simple technique, then that will be one ring counter. In the ring counter, you fix the timing. So in that timing, let for 10 seconds, this master will be connecting to slave. For next 10 seconds, this master will be connecting to slave. For next 10 seconds, this master will connecting to slave. If you remember, ring counter output is same like your decoder output. 100, then 010, then 001. So as it is a counter, you can fix the timing. For how many clock cycle master is going to connect the slave. So ring counter, it is like the simple arbitration technique. If someone is asking you what is the practical use of ring counter, you can say in the arbitration. Okay. So after this X stands for number of slaves. Okay. So next there is one protection. Okay. Okay, this protection I will be telling later. Okay. Okay, so now if I'm going to the data transfer, so some common things that I'm going to use, one is P address. Address means this is the 32-bit address. Either it is for write or it is for read. Now whether the address will be for write or for read, it will be decided by P write signal. P write signal, if it is 1 means it is a write. If it is 0 means it is read. Now, what is the signal you want to write? That is PW data. It is the 32-bit data that is written into slave. Like write data, there is also read data. So all these signals are sent from master. This read data, remember, master will be sending the data for write to slave, and master will be getting the data. Read data always come from slave, write data come from master. So 32-bit read data, read from slave. Okay, so write data, read data completed. Okay, so now there are some controlling signal that are, first is P enable, P select X is there. Okay, P enable means if it is 1, then only write or read operation happens. There is another signal known as P ready. Okay, so if the signal is 1, that means slave is ready to take, to write or read data. Slave is ready. Okay. Now if it is 0, that means slave is busy with some work. Slave is busy. So here master have to wait. Here master have to wait. So how it will be wait? It should not change any signal. Master